the chain rule allows us to differentiate a function that could be written as a composite function. Okay, so what we're going to do now is just review those quickly, and then we'll talk about the chain rule. And we'll also, after I give you the chain rule, and we'll go through one example of how to differentiate a function that would use the chain rule, we'll go through why the chain rule actually works as well. Okay, so let's suppose f of x equals x to the 6, and g of x equals 1 minus 4x squared. Okay, this over here, it kind of looks like fog, but it's f with a little circle, g of x. That would be written as f of g of x is equal to f of g of x. Okay, and what this means is that in the function f of x, which is x to the 6, we have to replace the x with this function g of x. Okay, so this is something to the power 6, and what that something is going to be is 1 minus 4x squared to the 6. Okay, now we could also try doing this. G of f of x, that would be g of f of x. Okay, and now what we're going to do is write out g of x. So that's 1 minus 4x squared. Instead of the x, I'm going to replace that with a set of brackets. And inside the set of brackets, I've got to put the function f of x, which is x to the 6. Okay, so these are composite functions. You would have looked at them in 30-1, but it may have been a little while, so that's just a little refresher. Okay, now, derivatives of composite functions. Okay, if f prime of x and g prime exist and f of x equals f of g of x, then f prime exists and is given by this product. Okay, f prime of x is equal to f prime of g of x times g prime of x. Okay, so I would actually write it like this. F of g of f prime, wait, hold on. Let's do it this way. If f of x equals f of g of x, capital F. Okay, then capital F prime of x equals f prime of g of x times g prime of x. Okay, now we're going to do one of these just to see how this whole thing plays out, and then we'll see why this works the way it does. Okay, so let's suppose we're looking for d by dx of 1 minus 4x squared to the 6. So in fact, this is exactly what we found right here. Okay, so our outer function is this something to the 6. And our inner function is 1 minus 4x squared. Okay, so f of x is x to the 6, something to the 6. Our inner function is this 1 minus 4x squared. Okay, so this is going to equal f prime of that. So f prime of that, if you thought of what's the derivative of something to the 6, that's a power rule, right? So we take the exponent, we bring it out in front, 6 times that something. Now that something has to be the g of x. In that case, that's 1 minus 4x squared to the 5. So that is this piece, the f prime of g of x, times g prime of x. Now g of x is 1 minus 4x. The derivative of that is negative 8x. And that's the derivative of the entire thing. Okay, and you would probably write, 6 times negative 8x is negative 48x times 1 minus 4x squared to the 5. Okay, so I would write this as dy by dx. Okay, so this is the derivative. Now, why does this work? Well, I'm going to go on to another page to look at why, so that I have some room to work with. It's not as complex as the product rule, so that's good. Why does this work? Well, let's suppose that we let y equal f of g of x. Okay, and I'm also going to let u equal g of x. Okay, so I'm going to do a substitution for g of x. Well, if u equals g of x, then this could be written as y equals f of u. F of u. There's an of in there, by the way, in case you were wondering. Okay, so far so good? Okay, so if I were to look for du by dx, this would equal g prime of x, right? The instantaneous change of u compared to the instantaneous change of x would equal g prime of x. And here, dy by du, now this variable is u, not x. So this is going to equal f prime of u. So far, so good? Okay. Now, dy by dx, because that's what we're really interested in, right? We've got y, we want dy by dx, equals dy by du times du by dx, because these can cancel. Okay, if we sub in the expressions for dy by du, well, dy by du was f prime of u. Du by dx was g prime of x. Okay, but we still have a u in there. So now we have to go and sub back, what was u originally? What was that? G of x, yes. U was g of x, so we're going to go and sub g of x back in there. And we're going to get that dy by dx f prime of u, which is g of x, times g prime of x. And that is the chain rule. And this is an incredibly, incredibly useful rule for differentiation, because in reality, a lot of functions can be written as a composite function. Okay? One of the challenges, though, is to figure out where's the composite function, what's the outer function, what's the inner function, because a lot of times, most of the time, that's not actually given to us, right? We went through the first one where we came up with the composite function ourselves, but that's not typical, and we're going to look at that as well. Okay, so here's another one where we have this function. We have to come up with, well, what is the composite function for this function? What's the outer function? What's the inner function? Okay, and so this is d by dx of the square root of 4 minus 2x cubed. So the original function is y equals the square root of 4 minus 2x cubed. Okay, that can be written as 4 minus 2x cubed to the 1/2. Okay, what do you think the outer function is? Yeah, x to the 1/2, that's right. X, this is the outer function, x, the brackets to the 1/2 is the outer function. The inner function is 4 minus 2x cubed, exactly. And as soon as you figure that out, you can differentiate. Okay, so dy by dx, we have to differentiate the outer function first. So that will be 1/2 times bracket to the negative 1/2. But instead of just putting an x in there, we're going to put the inner function inside, because it's f prime of g of x. So that's 4 minus 2x cubed to the negative 1/2. And then the inner function is 4 minus 2x cubed. What's the derivative of that? Correct. Times negative 6x squared. Okay, now this needs some cleaning up, okay? Because, you know, we've got like a negative exponent. There's a fraction over here. Okay, so let's actually simplify this a bit. So in the numerator, I've got 1 times negative 6x squared. So that would just be negative 6x squared over, this 2 is in the denominator, and then I can bring this down, right? Because this is a negative exponent that's currently in the numerator. And I can also, at this point, if I want to, write it as a radical again. Okay, and then there's one more thing that I can do to simplify. Can anyone see what it is? Yeah. Yeah, 6 over 2 is 3, right? So this is going to be negative 3x squared over the square root of 4 minus 2x cubed. Okay, so we're going to do a bunch of examples, because really the way that you get good at doing the chain rule is to practice it a lot, because like the tough thing is recognizing the outer function and the inner function. Okay, so here's another one. Y equals, okay, so here, by the way, I didn't actually type this out, but given y equals 1 over the square root of 2x minus 4x squared, we want to find y prime, or dy by dx. Okay, where would you start here? Yeah.
We could bring the root 2x minus 4x squared up and put it as a negative exponent.
Yeah, I would write this radical as a negative exponent, right? Because this is 1 over 2x minus 4x squared to the 1/2. So in the numerator, it's going to be y equals 2x minus 4x squared to the negative 1/2. Okay, and now once we have it written that way, it becomes more clear what the outer function is and what the inner function is. Okay, so outer function would be bracket to the negative 1/2, right? X to the negative 1/2. Inner function is 2x minus 4x squared. Okay, so y prime, we've got to take the derivative of the outer function first, which is negative 1/2 bracket to the negative 3/2, because that decreases by 1. Inside the brackets goes that function, 2x minus 4x squared, times the derivative of the inner function. What's the derivative of the inner function? 2 minus 8x, right. Okay, and then again, we've got to do a bit of simplification here. So I'm going to do this in a couple steps. This will be in the numerator, negative 1 times 2 minus 8x over 2 times 2x minus 4x squared to the 3/2. Okay, I could do that. And then there is some simplification I could do here. Some more. Can anyone see what it is? Yeah. Yeah, the numerator can be factored, right? You can pull out a 2. So, well, actually, I'm going to move over here because I'm going to run out of space. Y prime equals, well, this is going to be negative 2 plus 8. Can I just write this as negative 2 plus 8x? Then it's easier to factor. Well, it doesn't really make a difference, I suppose. So if I pull out a 2, let's say, from here, I'm going to be left with negative 1 plus 4x over 2 times 2x minus 4x cubed. No, squared, my bad, to the 3/2. Okay, and then the 2's cancel. Okay, if you want to write that in radical form, you could. Be the square root of this entire bracket cubed. You could leave it as a rational exponent as well. So this is negative 1 plus 4x over, I'm just going to leave it as a rational exponent. The one thing that you have to remember with square roots, though, is that the value that's inside here must be positive, right? So again, if you're thinking ahead to where is this differentiable, if it's easier for you to think along those lines when it's in radical form, you may want to revert to putting that in radical form. And because this is an odd number, when you cube it, right, negative number cubed is a negative number, so that's still going to keep it negative. Okay? All right. All right, here's another one. Given y equals 2u cubed minus 5u, and u equals x cubed minus 7, find dy by dx, and this notation means at x equals 2. What is dy by dx at x equals 2? Okay, well, where do you think we'd start here? There's a couple of ways that you could approach this, actually. What do you think? Yeah.
Could we substitute the u into the y function?
Substitute like this, x cubed minus 7 into here. Yep, we could. So y would be 2 times x cubed minus 7, what is that? Cubed? Minus 5 times x cubed minus 7. Okay, we could do that. Yep. And then what? Yep. What do you think? Is this a composite function? Yeah. This is, uh-oh, what's going on here? I'm getting, oh, there's messages going along for, let me just quit Microsoft Teams. There we go. Okay, yeah, this is a composite function. Okay, so what we could do here is we could find the derivative of the outer function. This one looks a little trickier though because the outer function has 2 terms, right? And then multiply that by the derivative of the inner function. Okay, so pretend that these were just x and x. Okay, the derivative would be 3 times 2 is 6 times x squared. But instead of the x, what are we going to have? That. Minus, what's the derivative of 5x? Just 5. So we don't need to multiply by that. Now this entire thing needs to be multiplied by the derivative of the inner function. The derivative of the inner function is what? Yeah, it's 3x squared. Okay, now, what we're actually being asked for here is to find dy by dx when x equals 2. Do we need to simplify this to do that? No, we can just sub 2 in for x right now, right? So dy by dx when x equals 2 is going to be 6 times 2 cubed minus 7 squared minus 5 times 3 times 2 squared. It's a bunch of bed mass, but we can handle that. And that is okay. What is that? 2 cubed is 8 minus 7 is 1, right? Okay, so 1 squared is 1. So this is 6 minus 5, which is 1. Phew. And then this is 4 times 3, which is 12. That's one way of approaching this. Okay, do you guys want to see the other way? Okay, the other way of approaching this is to remember, where am I going to have room? I'm going to do it down here. So what was this? It was y equals, what was it? I can't remember. 2u cubed minus 5u. And u equals x cubed minus 7. And we want to find basically dy by dx. Right? Okay, so one way that you can do this if you're struggling a little bit with, okay, that seemed kind of complicated, is to remember that dy by dx equals dy by du times du by dx. Okay, so here, dy by du is 6u squared minus 5. All so far so good? Okay. Du by dx is 3x squared. Okay, so to get dy by dx, we have to multiply 6u squared minus 5 by 3x squared. But we don't want u in there. We only want x's in there. So we can now do the substitution at this point rather than substituting in that x cubed minus 7 at the beginning. Okay, so we can now take this and sub in there. And get the same thing. Oh, sorry, this should be squared because it's 6u squared minus 5. And a lot of people find this sort of thing easier. Okay, you have to remember this though. So far, so good? Yeah? Okay. Okay, now I gotta backtrack a little bit because we missed something. Okay, so if g is differentiable, if g is a differentiable function, f of x equals, and f of x equals g of 4x cubed, what would f prime of x be? Okay, so g is differentiable, f of x equals g of 4x cubed. Okay, f prime of x in this case is going to be the derivative of the outer function, so g prime of, instead of x, the inner function, times the derivative of the inner function. The inner function in this case is 4x cubed, so the derivative of that is 12x squared. Okay, so we can't actually come up with a function because we don't know what g of x is, but we can come up with the derivative of f of x in terms of g of x. Okay, and similarly, if g is a differentiable function and h of x equals 4 times g of x cubed, well, now it's the other way around, right? G of x now is not the outer function, it's the inner function. And the outer function is 4x cubed. G of x has replaced x. So now we have to take the derivative of the outer function, which we actually know what that is. It's the 4x cubed, and multiply it by the derivative of the inner function. Derivative of the inner function is just g prime of x. So here, h prime of x is going to be 3 times 4 is 12 times g of x squared times the derivative of the inner function, which is just g prime of x. Okay, so these types of questions, you have to have a really good understanding of the chain rule to solve them. Yeah. Scroll down, this one. Yeah, this part. Yeah. I should also probably get out of the way. Probably make a better door than a window. All right, are we good? Yeah? Okay. Okay, so here is another one. getting a little bit more complicated here. So f of x equals 2x minus 5 to the power 5 times x squared plus 4 cubed. Find f prime of x. So we're multiplying two things together. So what rule do you think we have to use there? Product rule. Yeah, gonna have to use a product rule. But each of those things is a composite function. So we're also gonna have to use the chain rule. We're gonna have to use both. This happens a lot as well. This is gonna be a product and a chain rule question. That's one option. The other option, by the way, is that you could expand. You could multiply 2x minus 5 by itself 5 times, and multiply x squared plus 4 by itself 3 times, and then multiply those two things together. But that would not be fun, and you'd be likely to make an error somewhere along the way. So I wouldn't recommend doing that. So option 1, expand and use power rule. But this is not practical. Okay. Option 2, use product and chain rule. And that's what we're going to do. Okay? So we're basically multiplying two things together. So this is u, this is v. So we're going to start out with our product rule as we normally would. But when we find u prime and v prime, we're going to have to apply the chain rule. Okay? So u equals 2x minus 5 to the 5, and v equals x squared plus 4 cubed. Okay, what would u prime be? What do you think? Yeah.
5 bracket 2x minus 5 to the power of 4.
That's part of it, yeah, because this is the outer function, something to the power 5. So you've got to take the derivative of that first. So let's start with that. So it's going to be 5 times this to the 4. And the thing that has to go in here is this piece, 2x minus 5. Yeah, and then keep going.
And then 2.
Times 2, because that's the derivative of the inner function, times 2. And all together, that becomes 10 times 2x minus 5 to the 4. So that's u prime. I should have given myself a bit more room. Okay, so now that we have u prime, let's get v prime. What's that one going to be? Okay, so slow down a little bit. You're right, but take it one step at a time. Yeah. Squared, yeah. So that's the derivative of the outer function, which is something cubed. Yeah, and then times 2x, because that's the derivative of this inner function, x squared plus 4. Yeah, and then we can go 3 times 2x, right? Good, okay. And so all together, 6x times x squared plus 4 squared. All right, so we got our u, we got our u prime, we got our v, we got our v prime. Putting this all together, f prime of x equals u prime v plus u v prime. Just plug it all in. U prime is 10 times 2x minus 5 to the 4. V is x squared plus 4 cubed plus u, which is 2x minus 5 to the 5 times b prime, which is 6x times x squared minus 4 squared. And that is the derivative. Too big to fit on one line. Yeah. Oh, yeah, plus. There we go. Thank you. Okay, now something that you could do, by the way, actually we should do this because this is done sometimes, is this is actually factorable. We could factor this because if you look at these two terms, I've got 4 factors of 2x minus 5 to the 4 factors of 2x minus 5 here and 5 factors of 2x minus 5 here. And I've got 3 factors of x squared plus 4 here and 2 factors of x squared plus 4 here. And then between the monomial terms, I've got a 10 and a 6x. There's a common factor of 2. So you could actually factor out a GCF. And I want to practice doing that because we do that sometimes. Okay? So if we factored out GCF, then f prime of x would be, okay, so between the 10 and the 6, the 6x, there's a GCF of 2. Okay? Between the 2x minus 5 to the 4 and the 2x minus 5 to the 5, there's 4 of them that they share, right? So we've got 2x minus 5 to the 4. And then between the x squared plus 4 to the 3 and the x squared plus 4 to the 2, there's 2 that are shared. Okay? And then we have to say, okay, what's left over? From here, I've got 5 left over. Yes? Okay. I don't have anything left over from that piece. And here I've got an x squared plus 4 left over. Okay? And then from here, 2 times what is 6x? I've got a 3x left over. And I have 1 factor of 2x minus 5. And no factors of x squared plus 4. Okay, and then we could go even further, actually, because we can expand and simplify this piece. It can be done. And collect like terms. So because I don't want to write the whole line again, I'm going to do that off to the side. So let's see, we're going to have, what is that, 5x squared plus 20 plus 6x squared minus 15x. Is that right? I think so. Minus 15x, yes. So we're going to have 11x squared minus 15x plus 20. Okay, so this whole thing becomes, in factored form, 2 times 2x minus 5 to the 4 times x squared plus 4 squared times 11x squared minus 15x plus 20. There you have it. Yeah. Do you have to factor out the GCF? You're shaking your head, no. I would say it's a good idea. Yeah.
How do you know when to like stop? Because like up there
You could expand. I wouldn't expand. Things are good in factored form. They tell you things about the function. Yeah. I would say things are better in factored form. I mean, listen, this is not mathematically incorrect, right? So if I was assessing, can you apply the chain rule? If you can get to this piece, you can apply the chain rule, right? The rest of it is your algebra skills. Okay. But, I mean, is it good to do? Yes, because if it's fully in factored form, again, it tells you more about the function. If the derivative's in factored form and simplified, it tells you more about the function. Okay, so I'm not going to give you a yes or no answer, I suppose. Depends what I'm assessing. Depends what you're trying to know about the function and its derivative. Depends. That's the worst answer, isn't it? It's the worst answer. Okay. Here's another one. Let's keep going. All right, so here we've got m equals 3x over x plus 2 to the power 4. Okay, so what tools do we need to use to differentiate this? What are our options? Yeah. Yes, so we could use the chain rule for sure because outer function, inner function, but the inner function is a quotient. And so to differentiate that, we will have to use the quotient rule, okay? Now, you could, if you wanted to, expand the whole thing, multiply this by itself 4 times, but again, that's a big pain. So what's going to be most efficient, okay? And what's going to decrease the likeliness of careless errors? Those are 2 things that you should think about, okay? So we're going to use the quotient and the chain rule here, okay? So to find dm by dx, well, we have to take the derivative of the outer function first. Derivative of the outer function is 4 times 3x over x plus 2 cubed times, well, the derivative of this is, again, a little complex. So that's also something you may want to do off to the side. Okay, so if we were to do d by dx of 3x over x plus 2. Okay, well, we got our u, which is 3x. U prime would be 3. We got our v, which is x plus 2. And v prime is 1. So this is going to equal u prime v minus uv prime over v squared. Okay, so that is, what is that? 3 times x plus 2 minus 3x times 1 over x plus 2 squared. And if we simplify that a little, let's see what we get here. So we're going to get 3x plus 6 minus 3x. So 3x minus 3x is 0, so this is just going to be 6 over x squared, x plus 2 rather, squared. Okay, so times 6 over x plus 2 squared. Okay, and now I see a bunch of stuff that I can do here. I can see some common factors in the denominator. So if I distribute this cubed, right, not that I'm going to expand everything out, but I'm going to have 4 times 3x cubed is 27x cubed over x plus 2 cubed. I can do that. That's not too hard. Times 6 over x plus 2 squared.
Please return to class. VM Jones, return to room 272, please.
Okay. Well, now I have 2 powers in the denominator with the same base. So I can add their exponents. And I can multiply out all of these numerators because they're all just monomials. Okay, so 4 times 27 is 108 times 6. What's 108 times 6? Hold on, 648? Can someone check that? 8 times 6. I think it's 648. 4 times 27 times 6. Who's going to check it for me? Is it 648? Okay. That used to be my party trick, but I haven't gone to a lot of parties since I've had children, so I'm a little off my game. And this would be to the 5. Okay, now again, do you have to go this far? Could you leave it over here? Well, again, if I'm assessing the chain rule, if you can get to here, you know how to do the chain rule. Okay, but the more algebra skills you have, the more options you're going to have when you're trying to do stuff with calculus. Because you have to draw on all those skills when you're trying to solve problems. So I'm going to show you all of this. In this one, it's not as important because in the denominators, again, you can see here we've got a denominator of x plus 2, and that has the same denominator of x plus 2. I can see that there's going to be, it's not going to be differentiable, for example, at x equals negative 2. Right? But I could see that from this form as well. So some of this is just done so that you can get exposure to some of the algebra techniques as well, to put your minds at rest a little bit. Okay? All right. This is our last question. Okay. And this guy, we need to apply the chain rule not once, but twice. Can you guys see why? Can anyone see why? Yeah, because I've got something cubed. So our one outer function is the something cubed. But then inside this radical is something to the power 1/2. And I've got another function in there. So I'm going to have to apply this twice. Okay, so this is kind of like an f of g of h of x situation. Okay? Apply chain rule twice. Okay, so let's start with the easy part. To get the derivative of this outer function, that's just something cubed, it's going to be 3 times that something squared. That's nice. Now we need to multiply by the derivative of this. Okay? Now, this inner function is in two parts. So to get the derivative of that, we take the derivative of each piece. Okay? This, I will remind you, is actually x squared minus 4 to the 1/2. Right? Okay. So the derivative of that piece, what's the derivative of that piece? Because that's going to be the first term. Well, let's do the easy part first. What's the derivative of this piece? Okay, that's the easy part. Okay, what's the derivative of this piece? X minus 4 to the 1/2. What's the outer function there? Yeah, something to the 1/2. Yeah. So the derivative of that is 1/2 times that same something to the negative 1/2. And that something in there is x squared minus 4. And then we need to multiply that by the derivative of the inner function. What's the derivative of the inner function? 2x. There we go. It's tricky, tricky, tricky. Okay. Whew, and now we're going to simplify this a bit. Let's see what we get. Okay. So we'll leave this alone for now. Okay. And this, okay, well, this will move down to the denominator. So I'm going to get times 1 over 2 times x squared minus 4 to the 1/2 times 2x minus 1. Okay, well, what happens with this and this? Those will cancel, yep. That's nice. Okay, so this becomes, this is still the same, I'm not going to do anything here. Okay, this is going to become x over x squared minus 4 to the 1/2 minus, this is like 1 over 1. So what I'd like to do is have a common denominator here. What do I need to multiply this by to get a common denominator? Right now, this denominator is x squared minus 4 to the 1/2. This one's just 1. What would the LCD be there? Yep. Yeah, it's just this denominator. So I'm going to multiply this guy, I should move this bracket out a little bit, by x squared minus 1 to the 1/2 over x squared minus 1 to the 1/2. Okay, and then this becomes x minus x squared minus 1. Why did it become 1? It's a 4. Sorry, 4 to the 1/2 over x squared minus 4, there we go, to the 1/2. Okay, and now what I'm going to do, oh, look at that. Isn't that a common factor? Those are the same factor, except the order of the terms is reversed there. Is it not? Look at this factor. It's x minus basically the square root of x squared minus 4. This is root x squared minus 4 minus x. That's interesting. Okay, so I can keep going here a little bit. Okay, let's see. 3 times the square root of x squared minus 4 minus x squared. Now I'm going to factor out a negative 1 here. And I'll put this back into radical form. Times negative 1 times negative x plus the square root of x squared minus 4 over the square root of x squared minus 4. Huh. Well, now I've just found myself another factor of the square root of x squared minus 4 minus x. So all together, f prime of x equals 3 times negative 1 is negative 3 times this factor cubed, the square root of x squared minus 4 minus x cubed over the square root of x squared minus 4. And I believe now we're done. We're done this derivative and we're done for today. And this one I will tell you is complex, right? Particularly to get to here. Even just getting that first line is quite complex because you've got to apply the chain rule twice, right? But yeah, the simplification is complex. And again, I'm showing this to you so that you can have exposure to it, so that you can maybe pick up some of these tricks. Okay? All right. That's it for today.